So when you first open up Matlab, it's really easy to think of it as just, a superpowered calculator. But that's kind of missing the whole point. Its real power, the thing that makes it so special, comes from a totally different way of thinking about math. And today, we're going to unlock those secrets. So what is this big secret weapon? What makes it the go-to tool for so many scientists and engineers? Well, it really all boils down to one single, powerful idea. It's actually pretty simple when you get down to it. Matlab doesn't think about one number at a time. It thinks in entire collections of numbers, what we call arrays. And once you really get that one concept, everything else just clicks into place. Okay, let's dive into this foundational idea, the power of arrays. This is what lets you run calculations on massive data sets with just a single command. It's really where Matlab gets its incredible speed. So to see how this all works, we're going to use these two simple matrices. We'll call them A and B. Try to keep them in your head because we'll be coming back to them for the next couple of examples. Now, at first glance, things seem pretty straightforward. If you add A and B, Matlab does exactly what you'd expect. It just adds the matching pieces together. So 1 plus 5 gives you 6, 2 plus 6 gives you 8, and so on. Subtraction, yep, works the exact same way. Easy enough, right? But this is where we hit a really important fork in the road. Because when it comes to multiplication, Matlab has two completely different ways to do it. Both are super powerful, but you gotta know which one you need. So if you just type A asterisk B, you might be a little surprised by what pops out. You get this, 19, 22, 43, 50. And no, that's not an error. This is a very specific, very fundamental operation from linear algebra called matrix multiplication. It's incredibly useful for higher-level math, but it's definitely not what most of us expect to see the first time. And that brings us to the big question, right? What if you did just want to multiply 1 by 5, and 2 by 6, and 3 by 7? The simple way. How do you tell Matlab that's what you want to do? The answer is this one, single character, the dot. Seriously, this little guy is probably the most important operator you're going to learn when you're just starting out. This tiny dot is your key. It unlocks what we call element-wise operations. It basically gives you precise, piece-by-piece control over every single calculation you do. Let's look at the difference side by side, because this makes it super clear. On the left, you've got that standard matrix multiplication. But on the right, see how we added that dot right before the asterisk? That's you telling Matlab, hey, ignore the formal rules for a second, just multiply the matching parts. And boom, you get the answer you were probably looking for all along. 5, 12, 21, and 32. It's that simple. The dot gives you control. And hey, this isn't just a one-trick pony for multiplication. You can use the dot for element-wise division, or even for something like raising every single number in a matrix to a power. It's your universal signal for do this to each piece individually. Okay, time for our second big secret of the day. If the dot was all about giving you control, our next tool, the backslash, is all about solving really complex problems with just incredible simplicity. So, think back to algebra class. Remember problems like this? A system of linear equations? Now, sure, you could solve this by hand with substitution or something, but what if you had a system with thousands of equations? That's where Matlab just shines. The way Matlab handles this is just so elegant. It's a three-step process. You take your problem, you set it up in this standard matrix form called AX equals B, and then you solve the whole thing with one operator, the backslash. And setting it up is way easier than it sounds. All you do is pull out the coefficients, the numbers next to x and y, and put them in a matrix we'll call A. Then you take the constants from the other side of the equal sign and put them in a vector B. And that's it. The problem is now perfectly set up for Matlab. And now for the magic part. All of that complex algebra, all that work, it gets solved with this one single line of code. You're not even telling Matlab how to solve it, you're just describing the problem. It handles all the heavy lifting. And just like that, you get the answer. X is 2.75, Y is 0.75. There's no manual calculation, no chance for a simple mistake, just a clean, fast, precise solution. And listen, this isn't just some convenient little trick. This is how the pros do it. The backslash operator is highly optimized under the hood in Matlab, which makes it faster and more numerically stable than other ways you could solve it. Trust me, it's the preferred method for a very good reason.
All right, let's bring this all home. What we've really uncovered today aren't just a couple of commands. They're two fundamental tools, two core concepts that are absolutely key to working fast and efficiently in Matlab.
So let's just quickly recap the two keys we've unlocked. First, you've got the dot operator. That's your tool for element-wise control, for doing those direct, piece-by-piece calculations. Then you have the backslash. That's your powerhouse shortcut for solving entire systems of equations. If you can master these two, you've basically mastered the backbone of how computation gets done in MATLAB. You've just unlocked two of the most powerful ideas in MATLAB. Seriously. You now have the tools to take total control of your calculations and to solve really complex systems with ease. So the only question left is, what problems are you going to solve first?